Hello everyone and welcome to this video. In this video, I'm going to walk you through 20 labs from CYBE6217 Identity Access Management course taught by Professor Tchakounte. Labs 1. Assigning limited sudo privileges. What this lab is about. Lab 1 is about understanding. Not all administrators need the same level of access. In real organizations, different people have different job roles, and their system privileges should match exactly what each job requires, nothing more. This principle is called the principle of least privilege, and is one of the most fundamental concepts in cybersecurity. In this lab, we create three users on the Alma Linux line virtual machine: Lionel, Caitlin, and Maggie, and we assign each of them different level of sudo privileges. The procedure is as follows. First, is to create the user account using the user add command, and then set a password for each one using the pwquality command. This is the standard way to create users on Alma Linux or CentOS. After that, we open the sudo file using vsudo. It is very important that we always use vsudo and never open. Lab 2. Disabling sudo timer. What is Lab 2 about? Lab 2 explores sudo timestamp timer. By default, when you enter your password for a sudo command, Linux remembers your authentication for 15 minutes. Within that window, you can run more sudo commands without typing your password again. This is the timer, and this lab teaches us how to control it. In some high security environments, even a 15-minute window is too long. If someone walks away from their computer without locking it, another person could run privilege command during that window. This lab shows us how to reduce that risk. The procedure. We start by demonstrating the default behavior. We run 3 sudo commands in a row and observe that only the first one asks for a password. The other 2 run silently because the timer is still active. This is normal and comfortable for a day-to-day use. Lab 3. Creating an encrypted home directory. What is Lab 3 about? Lab 3 is about protecting user data at rest using home directory encryption. When a home directory is encrypted, even if someone removes the hard drive from the computer and mounts in another machine, they cannot read the files inside without the encryption key. This is critical for laptops, shared servers, and any system that handles sensitive personal data. This lab is performed on Ubuntu 22.04 and uses a tool called Encrypted, which is that cryptographic file system built into Linux kernel. The procedure. Lab 4. Setting password complexity criteria. What is Lab 4 about? Lab 4 focuses on enforcing password complexity requirements using PAM, the Pluggable Authentication Model Framework. PAM is a system Linux used to handle all authentication, and it can be configured to reject passwords that do not meet organization security standards. Weak passwords are still one of the most common causes of security breaches. This lab teaches us how to enforce minimum standards so that users cannot set passwords like their names, their date of birth, or simply dictionary words. The procedure. On Lab 5. Setting account and password expiry data. What is this lab about? Lab 5 covers account and password lifecycle management. In an organization, accounts and password cannot be left active indefinitely. Former employees must have their accounts deactivated. Passwords must be rotated regularly. Users should be warned before their password expires so they are not suddenly locked out. All of this is controlled using a tool called chage, which stands for change age. The procedure. We begin by creating a user called Samson with a built-in account expiring, then using the E flag with user add. The date is set to 13th of June 2025. After creation, we run chage on the account to list all the aging information and confirm the expiry date was applied correctly. When we use user mode with the E flag to update the expiration date to the 31st of July 2025, run chage L18 confirms the change was applied. Next, we assign Samsung a password and then immediately expire it using the passwd. This forces Samsung to change his password the next time he logs in. We verify this with change L, then switch to Samsung's account and see the false password change in action. Finally, we use change to multiple flags to configure a comprehensive password aging policy. We set a minimum of 5 days before a password can be changed, a maximum of 19 days before it can be changed, and inactive logout periods of 2 days after expiration, and warning period of 5 days before the password expires. The expected results. After creating Samsung's with the E flag, the change L output should show the account expiring field set to our choosing date. This confirms the account will be automatic. Lab 6. Detecting compromised passwords. What is this lab about? Lab 6 is one of the most interesting and modern labs in this series. It teaches us how to check whether a password has been exposed in a known data breach with or using the HaveIBeenPwned API. This service maintains a database of billions of passwords collected from data breaches around the world. If a password appears in the database, it means attackers already have it in their attack tools and it should never be used. What makes this lab technically elegant is the privacy preserving techniques it uses, called key anonymity. We never send the actual password or even its full hash over the internet. I'll explain exactly how it works. The process works like this. When we want to check a password, we first create a SHA-L hash if of it. SHA-H produces a 40-character hexadecimal string. We then take only the first 5 characters of each of the hash and send it to the API. The API responds with a list of all known breach hashes that start with those same 5 characters, along with how many times each has seen in the actual password or it completely hash leaves our machine. This protects our privacy completely. We start the lab by using the call command to query the API, passing the hash prefix 21BD1. This lets us to see the raw API response, a long list of hashes, fixes, each followed by a colon and a number showing how many times the password appears in breach databases. We then use the pwquality password script provided by a lecturer. We made it